The node we're going to look at in this tutorial is the scatter node. This is used for distributing objects across surfaces and potentially in a volume as well. And as such, it's very useful for placing objects, which is something that's important when making video games. The best way to show you is to demonstrate. So drop down a geometry node. Open it up, and then let's start by creating a sphere. Make it a polygon. Now, up until now, we've been placing objects onto points, and we've been using the existing points that are part of Houdini geometry. But these points might not be where you want them, and they're far too geometric. So the scatter node allows you to randomize points across the surface and completely ignore the existing points on that surface. So if we type in scatter and join it up, you can see we now have a completely new set of points that don't bear any relation to the original set, except that they all sit on the surface. So if we turn the surface on, you'll see that each of them is placed on a polygon. So the scatter node works on polygon surfaces rather than on the existing points. Let's put it on a grid node, it's probably a bit clearer. Now, we don't actually need any points on our surface, so we'll turn our rows and columns down to 2, so we just have a single plane. And you can see the way that the points are now scattered across the surface completely randomly. So let's take a look at some of the parameters. First of all, we have the total count, which is very simple. So we can determine exactly how many points we want on our surface. We also have an option for a max points. So if we were driving our force total count using something else, we might want to stick a maximum in there just to make sure we don't accidentally end up with too many objects, which could slow down the game or slow down Houdini. The global seed is, this reruns the calculation. So you're still getting the same total number of points and the same number of settings, but it's being calculated in a different way. It's useful to know that if your global seed is the same, so if I make it 2, and then I put all those parameters back again in the same way and have that seed of 2, I'll always get points in the same positions. But if the seed is slightly different, then those points will be different. This is useful if you're tweaking, say, placement of objects and you're not quite happy with where they are. Maybe one of them's in the wrong place. If you play with the seed, you can get them in a better position. We can randomize the point order, which is relatively random to start with, but this will ensure that the order of the points is completely random. So if you were doing something like generating particles, which depends on point order, it'll make sure that those particles are emitted in a completely random way. Another parameter that is quite useful is the scale radii. So if you imagine each point repelling all the other points, the radius is the area of influence of that repel. So if we turn it right down, you'll see that some of the points now sit quite close to each other. So we're looking at a completely random scattering now, as if it was created by a noise function. If we scale them up, they start pushing each other apart. And the higher and higher it goes, the less randomly they're distributed. This can be very useful if you've got, for example, quite a large object on each point, and you want to make sure that they don't ever overlap with each other. So you could put in a maximum radius and make sure that your points never go within that radius. The relax iterations is just how many times this is calculated. It's probably not something you need to play with very much. We are currently using the generate by density property for the scatter node. This is slightly unintuitive because what we're doing is using an attribute called density to distribute the points across the surface, but that attribute doesn't actually exist, which is fine. It means that all parts of the surface have an equal weight. But we can add in that attribute if we want to weight where the points will fall, and this is when you start to have a lot of control over where your points sit. But before we go into detail on the density attribute, I want to look at some of the other settings. So we can also scatter our points based on a count per primitive, which means that each primitive is assigned by you will be assigned an attribute called count, and then that count is used to decide how many points fall on that primitive. Let me demonstrate. I'm going to make this into a mountain node, which will make our surface a bit more interesting. And give this some more rows and columns. 50. So now we've got a more interesting surface to work with. And then we're going to use a VOP node to set up our attribute count for each primitive. You'll see very soon why I wanted to cover the attribute VOP before this tutorial, because it's really useful when you're scattering nodes. So we're going to be applying these attributes to our primitives, and I think I'm going to use the normal direction to drive the count. A normal is a vector, so it consists of 3 values and we only want 1. So I will convert it from a vector to a float. And let's just take the x direction. First time I tried this it crashed, and I think that was because it wasn't an integer, so we're going to convert this from a float to an integer. And we're going to bind it to an output called count. We can actually call this anything because we can change the name of the attribute that's in the parameters for scatter, but it's easiest to use the one that they give us by default. Now if we look, first of all, if we plug this in, you can see we're getting in our primitives we have a count value, which is, in the case of the normal, it's a fairly low number, mostly below about 0.3. And in some are positive and some are negative, because the normals could be pointing either in the positive or negative x direction. If we convert these to an integer, you'll see they're all 0 because the numbers were very small. So I'm going to multiply it and make them a bit bigger. And multiply constant. And let's make this 4. I'm starting to get some more values now. Try 10. Okay, so now we're getting values up to about 5 in some cases, which is a bit better. We also want to make sure that they're all positive numbers, because we can't have a negative number of points, which may be the other reason that it crashed. So I'm going to put a clamp in and clamp the values between 0 and 10, which means that nothing is ever lower than 0. And then we bind it to our count. And now we'll plug it in, and you'll see that you're getting a nice natural looking distribution across the surface. If we merge the mountain node in, you can see a bit clearer what's going on. So you'll see that the new points are mostly falling on the slopes that are facing in the positive x direction, which is exactly what we'd expect. This technique would be quite useful if, say, we wanted to look as if the snow had been driven across the landscape and was collecting on one side of little bumps. If we look, actually, to make this a bit clearer, I'm going to attach spheres to these points and turn the points off, and then you're not getting confused with the ones that are on the surface. So I'm going to create a sphere and give it a colour. Let's make it much smaller and copy it to the points. So now we can turn our point display off. And you can see a bit more clearly where it's falling on the surface. Let's turn the grid off as well. Make the spheres a bit smaller. Now, if you actually go in and look at the individual primitives, each one has a specific count, which will actually correspond to the count that it has in the attribute spreadsheet. We would need to be back on our surface to see that. And that count corresponds to the degree to which the slope is pointing towards the positive x direction. So this was a demonstration of how to use the count per primitive attribute, but in fact there's a much easier way to do this. We could be using the density attribute, and I'll come back to that in a minute. First of all, I just quickly want to cover texture space, which is, it's not something I've ever used, but it potentially could solve some problems for you. We have an error now because we don't actually have any UVs in our object at the moment. First of all, I'm going to go back to count by primitive and make a copy of this because we might want to come back to it later. Now, I'll put this back to texture space and we'll create some UVs. Do this by projecting UVs. And you'll see immediately that's solved the problem. We have, I think, a very low count at the moment. Yep. So let's increase them a bit. And scale them up a little bit. There we go. You don't have as many controls over the parameters of the texture space scattering. The reason you would find this useful is because it's independent of the position and placement of the object. So if, for example, I was to edit the surface, so let's stick an edit node in. I'll put that in before we do anything else with our mountain. And select some faces. and now try moving them, actually it hasn't worked because we need to create our UVs before the edit. Here we go. Now you'll see that the position of the points remains consistent even though we're moving the surface around. If we were scattering based on density, this very much wouldn't be the case because we're changing the surface typology and the points are being recalculated every time we change something. There's actually a really nice demonstration of this in the scatter help with some points being placed on a door. It's probably worth having a look at that if you want to understand exactly how the textures work. It's this one here. One more thing that we can do with the texture space is we can use a texture to drive the position of the points. So if we switch on density texture here, I think you'll find the default picture as a butterfly. So we've now got access to this density scale, so if we ramp it up, you can see, let's get rid of edit. You can see that we have the Houdini butterfly picture being drawn in our points. So that's another way you can use texture space to determine the position of objects. For example, if you wanted a layout of fields with fields boundaries, let me show you. I have a texture here that consists of a black background with white field edges. So you could draw hedges or trees along the boundaries of fields. Now let's go back to our density and look at it in a bit more detail. So before we start, I'm going to make our surface a little bit more interesting. So let's increase the height a little bit on our grid and put the material on it. So if we go into the material palette, and I'm going to start with a dirt material and drop on some desert texture that works quite well across a landscape. So in the textures here, I'll change this to desert shrubby. Put normal map on it. Now, in order to add a material to your object, you drop in a material node, and I'm just going to put this in just before it comes into the merge node because we don't need it to drive our scattering. And then connect up the material that we've just created. And we want to change our projection a bit. We're not using projection for anything else now, so we can play around with it. Okay, so we have something that looks a bit more like desert now. I have a Houdini digital asset that I created to make low polygon plants and objects. So I'm going to load this in. I'll put a copy of this with the tutorial so that you can play around with it. It's called Low Res Plant, and it just consists of two planes with a plant on them. You might find that you're getting blue shadows on the back side. If that's the case, then turn off tint back faces and it'll look a bit more natural. Now, all you need to do to change your plant is apply some textures. I'm not going to use the roughness texture here. So I have some grass. Here we see we have a little patch of grass, and I'm going to plug that into our copy to points node instead of the sphere. We can delete the sphere. So now we have something slightly more natural looking. They're probably a bit small, so I'll increase the scale a little bit, which you can do in the digital asset, and raise them down a bit so they don't all look like they're growing from a single clump. There we go. Now we're going to play around with the density attribute for our scatter node. So we want to turn on density attribute, which currently doesn't exist, so we get an error. And we don't need this attribute VOP anymore, which is creating a primitive count. So we'll delete that and make a new one. And this time we want to create an attribute called density. So once again we use a bind export and call this density. And to drive the position of the plant, I'm going to use the height, which is the y component of position. So first of all we want to break our position vector out into separate floats. So we'll do a vector to float. And then take the y value and plug that into our density. So if you take a look now at where the grass is being formed, it's only being placed in the areas that are in the positive y, so above the height of the grid plane. I'm actually going to turn the grid plane off because it's getting in the way. And I'm going to turn off the wire shading as well, so we'll just make everything smooth shaded. It looks a bit more natural. Now this probably isn't where we want our grass. We'd be more likely to see grass growing in the valleys, so we're going to use a fit node in order to change this. So let's take a look at where our density values are at the moment. If we look at the geometry spreadsheet, you can see the highest value is 0.87 and the lowest value is minus 0.6. So let's go back to our scene view and add in a fit node. So if we take our lowest value, let's make this minus 0.7 and the highest value 0.9. So now they spread quite evenly across the whole range. However, we want more of them in the valleys. So we take all the positive values and eliminate them. So we'll take this down to about 0, and we want to invert them so that we have the highest numbers where it was low and the lowest numbers where it was high. And we should now be getting some grass that sits in the valleys and is pretty much eliminated at above 0. If we increase the numbers on the scatter node, this should be a bit clearer. So I have a total count that's a lot higher now. So that's starting to look a lot more natural. Now we're still seeing points that are quite evenly distributed. If you remember, the scale radii pushes all the points apart. In nature we wouldn't expect all the grass to be an equal even distance apart. So if we turn this down a bit, we get a bit more clumping, which again looks a little bit more natural. You might also notice that all our vegetation is sitting at exactly the same angle. We can fix this using something called an Orient attribute. The Orient attribute is similar to the p-scale in that it's a built-in value that will be recognised by copy to points, and we can use it to rotate each of the objects sitting on the points. So if we go back into our attribute VOP and create, let's copy our density, and we'll create a new export called Orient. We want random rotation on our plants, so I'll use a node called random, and this is driven by a float called position, which is slightly confusing because it isn't position. We can use the point number to drive it because each is a unique value, and this will give us an output between 0 and 1 that's random. The Orient node uses a quaternion rotation, which is a rotation that's represented by vector 4, and it's very complicated to work it out, but we can quite easily convert an XYZ rotation into a quaternion rotation using a node called Euler to quaternion. So this is what goes into our Orient attribute, and we want to now take our random value and convert that into an XYZ rotation. So we'll do a float to vector, and we want to plug our random value into the Y component because we want our objects to rotate around their axis, around Y, and not in the X and Z direction. And one last thing we need to do is our random value is between 0 and 1, but we want it in radians, which a full rotation is just over 6 radians. So we'll multiply this by 6, and that will give us a much bigger range of values. So we'll do a multiply constant, but that's 6. And now you see we've got random rotation on our grass. While we're doing this, it might be a good idea to set up a p-scale as well and have a bit of variation in scale. So we'll make another bind export and call it p-scale, which, if you remember from previous tutorial, allows you to apply a scale to the points, which is then passed on to the objects that are attached to them. We can use our random value again. We probably don't want it to be completely random because then we'd be getting a scale of almost 0 in some of our objects. So we'll use a mix node, which allows us to blend between two values. So we'll blend between our random value and a value of 1. And plug this into p-scale, and now we're getting a bit of variation. We see that everything's got smaller. We could put another node in here to fix that, but it's as easy to go back to our original plant and scale it up here. We can use our bias on our mix node to adjust the degree of randomness that you're seeing. So here we have some extreme randomization, and if we turn it up to 1, there's none at all. Let's make them fairly random. Now let's try adding a different object in. So we'll copy this little group of nodes and hook them up to the merge node again. Now you'll notice all we've done here is double up all the pieces of grass that we already have because the settings are exactly the same. This is where the global seed can be quite useful. So if we just tweak this a little bit, you'll see that it reapplies these new pieces of grass in a different position. And we're going to load up a slightly different variant on the grass. I've got one here called seedy grass. Oops. That should be a normal, I think. No, that's right. So this grass is a little bit darker, so we might expect it to just grow right down in the hollows. So I'll go back into our attribute VOP and play around with our fit values a little bit. I want to eliminate that more from the heights. We might actually make that the max value a negative number. Yeah, so we're just getting it right down in the valleys. Let's also turn the total to count down a little bit. Now let's add some cactuses to our scene. So we'll copy all this again. And see if we can find a cactus. I'm going to add in the yucca. I've got the wrong way this time. There we go. So we have a very low poly yucca plant, and once again it's in the same position as our seedy grass. Now, yucca plant might not care so much about water, so you would expect it more evenly distributed across the landscape. So let's go back into our attribute VOP node, and instead of using our Y position to drive the density, we'll just use a noise. So we create a anti-alias noise node, hook this up to position, and it probably helps to hook this up to the color node as well to visualize it. At the moment all that's doing is tinting the yucca plants, but if we grab our output here and stick it into the merge node, we can make a temporary visualization so that you can see where these plants are being placed. So you can see where the light areas are, you're getting the yucca plants, and where the dark areas are, there are none. That distribution actually looks quite nice, so I'm going to unhook that again, and I'm going to, well, there's two ways we can do this. We can unhook the colour, but it's quite useful to visualize the colour. So what I'm going to do is in the copy to points node, I'm going to eliminate the colour, which I do using the little hat symbol, and then the colour is no longer being driven from the points, and it just uses the original colour of the model. I think we've probably got a few too many, so let's reduce our numbers on the scatter node. And let's also take our yucca and drop it down a little bit, because some of these look like they're floating. There we go. Now I'm going to continue adding vegetation to this landscape, but I'm not going to do it as part of this tutorial because it would get quite boring. What I'll do is I'll give you a copy of the final scene, and I'll give you a copy of the textures so you can play around with this yourself, and I'll put in some renders so that you can see how the final scene will look. So that's it for the scatter node. I hope you've enjoyed this tutorial. Please sign up and come back again.